Good morning. Today I'm going to present you my first lab. So it is about an object moving straight at a constant velocity. The purpose of this lab is to exemplify the physics principles of Newton's second law and the momentum principle. As you can see, Newton's second law is that the net force equals mass times acceleration, and the momentum principles is that the net force equals change in momentum over change in time, where momentum equals to mass times velocity. So the principles in action. Newton's second law describes how I had to push an object with the same force as the force of friction for the net force to be zero and let the pencil move at a constant velocity. The momentum principle. Since the net force was zero, the momentum of the object remained constant, so it did not change and the velocity did not change either. So now let's get into the experiment. The description of the experiment. First, the object selected to analyze was a pencil. The center of mass was selected to be the eraser of the pencil. The tip of the pencil was tracked with tracker for each time frame, and the data of position versus time were recorded by the tracker app. The origin was set to be the rightmost end of the screen, and the movement to the left is considered to be in the negative x direction. Here's the video of the experiment. So now I explain the system and the surroundings. The system was the pencil, with the eraser as its center of mass. And the surroundings were the table, my hand, and earth. The red arrow indicates the force applied by my hand. The orange arrow indicates the force by friction, which opposes motion. The upwards arrow indicates the normal force exerted by the table to oppose the force of gravity. Now the description of the computational model. The total distance traveled by the pencil was 57 centimeters in 3.7 seconds. The position changed in the negative direction by 0.001473 meters each hundredth of a second, so we could travel 57 centimeters in 3.7 seconds. The model printed the data along with the corresponding graph for the position versus time. So now let's compare the graphs of the predicted versus the experimental data. So both start and end at the same position, and both have the same average velocity, because they travel the same in the same time. Differences is that the predicted line is smooth while the experimental line is not, and the experimental line has not the same instant velocity throughout. Possible sources of error for this to happen was that in real life the applied force could not have been the most constant of all, as it's very difficult to apply the exact same force all throughout the experiment with my hand, and the computational model has the exact same velocity throughout the simulation, so that's why it was smooth. What if the positive and negative x directions were interchanged? The graph would be flipped upside down, with the curves having a positive slope, and the left direction would have been in the positive x direction. The results would basically remain the same, but with different signs, and the differences in the graphs would still remain constant. So what does this mean? This experiment means that having a net force of zero act on an object satisfies Newton's first law, as the object remained at a constant velocity when acted by no net external force. The forces acting upon the pencil were the applied force, so my hand, which was equal in magnitude than the force of friction, which opposes motion. Then in the y direction, the force of gravity downwards and the normal force from the table upwards cancel each other. Here's the link for my simulation program if you want to see it. Thank you.